Welcome. My name is Bob Tickleman. I'm a Principal Microsoft Technical Trainer. I'm happy to be your guide for Learning Path number 3, Developing Solutions that Use Blob Storage as part of the AZ-204 course. This learning path covers 3 major modules. One, we're going to take a look at what is Azure Blob Storage. We're going to take a look at a feature called Lifecycle Management, and then we're going to take a look at working with Blob Storage itself and connecting to it. These are 3 separate recordings, and this is the first recording of Module 1, Exploring Blob Storage. In here, we're going to take a look at the different types of storage accounts that you have and available for you to be able to build for durable storage. We're going to take a look at the features of a blob storage, how to configure it, how to have the different redundancy levels that are available for you, and finding which one might be best for the different services for your application use. Azure Storage Accounts is a regionally based way to configure the storage of a durable type of information. And we're going to see in a storage account, you have different types of storage that all fall into either what's called the unstructured or lightly structured nature. We're going to take a look at the different types of redundancy that you have available from that unstructured data, as well as how it's made it highly available to you and other options that you can use to configure it. Azure as a public service is global. We have over 67 regions currently available, and within a region, we have multiple data centers. An Azure Storage account can comprise up to 4 different types of data. 2 of them fall into the unstructured data, that's the file shares and blob storage, as well as a lightly structured form in tables and queues. These are going to be covered in other recordings within the series, but we're going to focus on blob storage, and I'll try and weave in some file storage in here specifically. When you take a look at the storage account and your configuration of the storage account, it falls into several categories. I'm going to come back to these slides, but let's describe what a storage account is, how it does what it does. We'll go through the configuration of a storage account and then come back to the slides so that you can see how this is all related to the learning materials. In a previous recording, I described the actual interface and how you interact with Azure itself. And so we have a user that might be looking at something. In this example, maybe I'm looking at a file called bob.doc. Remember, that is a type of unstructured data. It could be an XLS, it could be a JPEG, it could be an MP3, any type of this unstructured data that you're dealing with. To be able to gain access to Azure, you come through this thing called the ARM, or the Azure Resource Manager layer. You can do this, as I'm going to, through the portal, or you can access it through templates, PowerShell, or how most applications are going to access this data is going to be through some SDK or REST API that you're working with. That then goes down into a thing called a resource provider. This, for me, is the magic behind Azure, how it's able to do some of the features we're going to take a look at. And you're specifically going to connect to a thing called the Storage Resource Provider. Now, you're going to find out as we go through this module that all data in Azure is going to be stored 3 times. So that file that I thought I was looking at, bob.doc, is going to connect me to a storage resource provider, and it's then going to connect me synchronously. That's the key here, to 3 copies of that file. That synchronous copy is going to come in several forms of redundancy. And so that's the term we're going to use in the storage account, is how do I make it redundant? And I'm going to show some more examples of this in a few minutes. But that is going to be a synchronous copy. And so any change that I make to the file, so if I do something to it here, like put a red X in it, it synchronously or simultaneously copies that to all 3 copies. This is not a form of a backup. This is a form of high availability that now says if whatever stores that 1 copy and we lose it, we still have 2 other copies. This is not a form of RAID or redundant array of independent or inexpensive disks, where if you could lose 1 or more drives, but you could still lose access to the entire file. You're going to actually have this stored 3 separate times in 3 separate locations. Now, if you take a look at disks, and I had the benefit of going to one of our Azure data centers, talking to a data center manager, he pulled out of his drawer a hard drive, And he goes, the MBTF, or the mean time between failure rate of this drive, is 10,000 hours, which is a little over 6 years. When you take a look at 10,000 hours, but he says, when you get millions of these, they're failing every couple of minutes in my data center. I can't afford to have somebody going around rebuilding RAIDs and swapping out drives. So we don't do that. We just let the drive die, and then we don't use that one anymore. And when the entire unit of drives fails, then we replace the entire unit of drives. So it's managed at a completely different structure. So understanding that when you're connecting to something, you're going through the ARM layer, connecting to the resource providers. I now want to show you how this actually works and take a look at it from a perspective. And remember, we've seen this in another recording, a region, looking at US East here, in 2014 looked like this with multiple data centers, and in 2017 it looked like this. And in a previous recording, I talked about a thing called zone redundancy. Now, I want to give you a bit of an eye-winking moment that should be pointed out, is that not all services for storage is available in all regions. And I'll point this out when I get to the graphical interface. So again, I've got a green user here. They're going to have what is called zone redundancy in US East because it's available there. They're going to have 3 different zones. And the data centers that make up those 3 zones are managed by Microsoft. So maybe this one is zone 1, one of these is zone 1, and that's zone 1. This one's zone 2, this one is zone 2, and this one's zone 2. I got a zone 3 here, I got a zone 3 here for green user. Now, all the data centers will fall into one of those 3 zones for green user. I'm going to come into another user. I've got my purple user, and they have 3 zones where they might be zone 1, zone 2, zone 3, zone 1, zone 2, zone 3. So every instance of a zone is going to be different for different subscriptions and different regions that you're working with, but just understand that overall concept. So now jumping ahead, let's take a look at what happens inside of a data center. And I want you to remember that overall picture that I showed you earlier of coming through the ARM layer. So I'm going to draw this, and I'm going to have that file bob.doc that I drew previously. I'm going to draw it as a purple file. That is now going to be connected to a thing called a scale unit. This is not in the books, so I'm giving you a bit of extra information. A scale unit is a set of similarly configured resources that provide a single point of failure. So a scale unit has a whole bunch of nodes in it that are all going to be configured the same way, that have a set of TORs, top of rack switches, and PDUs, power distribution units, at the bottom. They're redundantly connected into the power grid, to battery backups, and the TORs are redundantly connected into the network connectivity you're dealing with. Now, I think that you'd appreciate that if bob.doc, remember we were going to have 3 copies of this, is actually going to connect to a storage resource provider who's going to then create 3 copies of that file. If those 3 copies of bob.doc were to be set into 3 different nodes within the same scale unit, that would be great. I could lose an entire node in the scale unit, thereby losing access to one file, and I would still have 2 copies. The problem with this is, if I lose the entire scale unit, I lose access to all of my copies that I'm working with. So that doesn't work for me. Is I'm going to build out multiple scale units of the same type. I'm going to still have my file bob.doc. And now the storage resource provider is going to put that 3 copies of that file across 3 different, the term is called fault domains. So now I've got 3 copies of that file, still across 3 different nodes and 3 different fault domains. So now if I lose a scale unit, a common fault domain, I still have access to my file. Now this is generically called, and you'll see this when we go to create the storage account, what's called LRS, or locally redundant storage. It's the oldest type of storage we've had. It's been around for a while. So LRS is going to create 3 copies of a file within inside of a single region, within inside of a single data center, but across 3 different fault domains. LRS. If we take a look at a feature called ZRS, or zone redundant storage, we are now going to spread the 3 copies of that file across 3 different zones within inside of the same region. Because remember, a storage account is still regionally based. So I still got my file bob.doc. And now what happens is I connect to the storage resource provider that is zone redundant, and I'm now going to create 3 copies of that file, but now across 3 copies in 3 different zones. I can lose an entire scale unit. Heck, I can lose an entire data center with inside of the region and still have access to my file. Now, life has taught me that anytime I give you something, we typically take something away. So this sounds great, but what is it costing me? Is it costing me more money? Is there some performance impact? And the answer is possibly. So when you take a look at the performance that you get at LRS, it's going to get you the highest possible performance, but it introduces a set of potential high availability that you're not willing to live with. Now, when you take a look at the performance at a regional level, coming back to this diagram, Microsoft commits that the communication across the region is sub 2 milliseconds. So you might have that file, remember, now in 3 different data centers across this region, and the performance might be slightly less than as if they were in the same data center on the same fiber channel you're dealing with. It's very negligible from a human perspective, but when you're, as an application developer, dealing with maybe thousands of objects that are appearing on your web page as pictures, and you have millions of users accessing them, this potentially could have an impact on a performance. And I'll discuss that when we get back into the overall picture. So hopefully that's introducing the idea of a ZRS versus LRS, 3 copies now, but now across 3 different data centers, still within inside the same region. We're now going to introduce a form called GRS, or globally redundant storage. Now, this can come in several formats. I can have just GRS, where it takes the primary copies and writes it 3 times inside of the same data center, but still across the 3 same fault domains. And then, remember, these are synchronously written. So all 3 copies are written at the same time. But then what happens is across regions in a thing called a region pair, we now create 3 copies in another data center in a region pair. Now, the region pair is controlled by Microsoft. So in the case of US East, it is paired with US West. We pick them for what is called data sovereignty requirements. And there's lots of benefits of this. So now, if we have a failure at the region level, Microsoft will fail over to the region pair and direct all requests for that file at a DNS level, reroute that traffic, and will now make this the primary region so that you can gain access to it. Now, they don't talk too much about this in the book. They just introduce the concept of the different types. But from an application developer, it's important that you understand what the benefits of this are and what you might have to build into your application to be able to account for this kind of interruption. Now, in addition to GRS, or globally redundant storage, they introduce a type called let me pick a different color. GZRS, globally redundant, zone redundant storage. So now what it does is it takes that bob.doc file and now it still creates the 3 copies, but now it puts them across 3 different data centers or zones within the primary region, and these are synchronously copied. But it copies the 3 copies to a locally redundant storage in the region pair you're dealing with. Now, both of the GRS and the GZRS also provide a read accessible. So you're going to get an RA, GRS. And so now what it does is it makes that second copy in the region pair read accessible. And from an application developer's perspective, you might send the request to the primary region. And if after a certain timeout, if you don't get a response, you could get a read request fulfilled by going to the secondary region. Now, our recommendation would be use this for only data that is changed infrequently, because the replication of that information to the region pair is time dependent, and it is not synchronously, it's async. It's asynchronously written, and Microsoft says that delta time difference could be up to 15 minutes. So I wouldn't use this for database replication. We've got better methods to do that, using log shifting and other ways within SQL to do it. But from a unstructured data perspective, these are the broad range of types of storage account that you can now have to make your information highly available with inside of your solution that you're building. So let's go ahead and take a look at how that might appear in the portal. We'll take a look at the options for creating a storage account, and then once I've created one, I'll go in and show some of the characteristics of the usage of the storage account itself. So with most resources, you're going to have to create, they need a subscription to bill it to, you need a resource group to associate it with. And in the case of a storage account name, this name needs to be globally unique. Very similar to other recordings that we talked about in the app service plans that needed to be globally unique from a naming perspective. We also had that requirement for Azure Functions. The same thing is going to be for your storage account. And you'll see in the demonstration, when I get into the usage of it, where this comes into play. So I'm going to come into Contoso. SA demo 1. I'm going to select US East. As we've described, it is our biggest region. It gets all the services first. And through the course content, you'll see that it refers to that not all services are available in all regions. And I'm going to point that out as I go through this. So I'm going to select my preferred method. I'm going to make this just a standard V2 storage account. Now we have the 2 options of standard versus premium, which were on that previous slide where we exited the presentation. And this is going to be where the vast majority of your storage accounts are going to fall into. This is where you're going to have all of the replication models and all of the features. When I switch to premium, you'll see that it reduces some of them, but it does give me the access to a feature called Ultra Disks. And I'll talk more about that as we go through the different disk types that are going to support this. So in US East, using a standard V2 storage account, I get multiple forms of replication. We talked about the LRS, GRS, so the locally redundant storage. We talked about ZRS, the zone redundant storage. And the 2 versions of global. There's global redundant storage, which makes it LRS in the primary region, and then it creates 3 copies in a geo-redundant region pair. And the GZRS gives me zone redundance in the primary region, and it copies those 3 copies asynchronously to the region pair you're dealing with. In the geo-redundant copies, you get this option to make it RA or read accessible. If I take that feature off, it makes this geo-redundant, so LRS in the primary region, 3 copies in another region that are not read accessible. And I'll talk more about this when we get into the usage in a later recording. Now, if I switch this from locally redundant in a standard v2, if I change my region, I'm going to come to Canada East. And we're going to see that some of the redundancies are not going to be made available. So now I'm in Canada East instead of US East. And if I take a look at my redundancy, I only get LRS and GRS. I don't get the zone redundant versions. I don't get ZRS and I don't get GZRS as available. I do have Geo and I can make it read accessible. So I only get 3 instead of 6 forms of replication based on that region requirement that I'm working with. Switch back to US East. Now, switching from a standard to a premium storage account, you're going to see that it now reduces not only the type of replication, you only get either LRS or GRS. Premium does not allow for any of the global or read accessible global options that are available for me. But what it's now going to do is very tightly control the types of storage that I have. I have block blobs and page blobs. Block blobs are that standard form of taking a look at a file that might be sequentially read. It's an XLS file, it's an MP3, it's a .doc file. That is typically the default that you're looking for of block blobs. Page blobs are slightly different, that are more associated with VHDs or the virtual hard disks that are associated with the virtual machines. And as opposed to a sequentially read file, it's actually a file, a blob, that has a whole bunch of random files in it. It's got EXEs, it's got DLLs, that they themselves might be consecutively read, but I might be using a whole bunch of different features. So a page blob is fundamentally different than a block blob, and they're used for very specific features. Now, when I get into blobs, you'll see there's a third type called an append blob, and I'll cover that when I get to that in the demonstration. But it also makes available this feature called file shares. Now, what this is going to do from a premium perspective, it provides for faster disks, and you can see it requires low latency. This is going to move from the standard drives, which are using what are called standard SSDs and premium SSDs. So those 3 types of disks all have different data throughputs and IOP performances that are rated for them. As little as, say, 2,000 IOPS, all the way up to about 50,000 IOPS, depending on whether it's a premium SSD, all the way down to, I said, the standard HDD. When you move to a premium storage account, you're now getting into what's referred to as ultra disks, where you're getting up over 160,000 IOPS. So significantly better performance, but a restricted number of types of drives and the types of replications going to come along with that storage account. Now, some of the other features that come along with the storage account under the advanced stage, we can take a look at the types of protocols that we're going to be using for this. We get into the types of storage. I can access this using a data lake storage for a hierarchical name structure. I've got my blob storage. I can use cross-tenant replication. I'm going to get into networking. We're not going to cover all of these right now, but I do want to take a look briefly at data protection. We now offer the capability to provide soft delete capabilities at the blob level, and I'll be demonstrating this in a bit. So I have by default the ability to recover deleted blobs within a container for up to 7 days by default, and I can actually recover deleted containers again for up to 7 days, and you can adjust these numbers. In addition to the soft delete capabilities, I also have the ability to do version control or version tracking. So this is not just the deletion of the blob, but if people come in and make modifications that might either create a corrupting change or maybe fundamentally change the data that's in it, and I want to go back to a different version. Now, this does not replace the requirements and the needs to be able to have proper backups. There is a limited number of versions that it keeps at the time of recording. I believe the number is 200. So you can go back up to 200 instances and go back to any one of those points in time, but you still want to be able to have a backup in case this process has been corrupted or circumvented for whatever purposes. So do not use this in place of a backup. Other things we want to take a look at, we've talked about the ability to have keys for the encryption. We talked about that all data is stored a minimum of 3 times, and that data by default is going to be encrypted at rest. The default configuration is to have Microsoft be the PKI, or the public key infrastructure, where we generate the keys to encrypt this traffic. Now, that also allows us to have what's called the key recovery agent that allows you that if you lose your keys to your storage account, we would be able to recover that. Theoretically, that also means that we then have the capability to potentially read your data. Now, we never would, but there is that potential, and whether it's a government organization or maybe federal regulations or some restriction that you have that says we cannot have at all anybody else other than ourselves access this information, we've now added the capability for you to have what's called a customer managed key, where you can now have your own PKI infrastructure generate the keys that are going to be needed to encrypt this data. But you'll notice that when I select this takes us out of the picture. Yes, there's no way that we could ever unlock this, but we can't also then assist you in recovering the keys if you lose that information. And you're going to see that we're going to make some recommendations that, in addition to your PKI infrastructure and being able to make that highly available, you might want to actually store this information in Key Vault, which I'll be covering in another recording. So all of these configuration features are going to be made available. Now I'm going to go through and create this storage account. And then we're going to go in and start to use some of the features. And then in other recordings on the storage account, we'll get deeper into some of those capabilities. So it's been able to create that storage account. I'm going to go into the storage account. In the overview tab, it's a common tab that you'll see in all of this. The structure is, looking at the blade down the left-hand side, which has unique attributes of the blade that you're looking at. And in the storage account blade, listed in the upper left-hand corner, I get a set of attributes that I can now take a look at. The overview page, you can see it's in a resource group. It shows you the location of the storage account. It shows you the type of replication that I'm working with. So all that general information. I'm then going to scroll down and take a look at a feature called Access Control, also known as IAM, or Identity Access Management, or another term that I'll use is RBAC, or the Role-Based Access Control. So 3 different names for exactly the same thing. This is going to use Microsoft Entra IDs to be able to control access not only to the storage account and what it can do and the properties of the storage account, but the actual objects in the storage account. We'll be showing you that in a bit. So I can get into what's called a role assignment, and I can actually add user accounts through usually a group membership to give them access to maybe have contributor capabilities where they can add, remove, copy, delete objects into the storage account. Or do they have just read capabilities? So access control, IAM, or RBAC. Now I'm going to scroll down a little bit, and I'm going to take a look at the data storages. And in this one, I currently only have container storage. And that was done from that selection I did on the first page. I'm going to do another storage account in another recording, which will show you the 4 types of storage that are available in a storage account: the container storage, the file share storage, the table storage, and the queue storage. But right now, this one only had containers based around that choice that I made of the type of storage that was going to be used. Now in here, I can create multiple containers. And you'll see this when I get back into the slides. You can't nest a container inside of a container. This is a flat structure that now I could create multiple containers, and maybe I have them for virtual machines or different projects. And having multiple containers provides a way to organize at the root level the blob storage management, but they share the common attributes of the storage account. So the region that they're deployed into and the type of replication. So I'm going to create this as AZ-204 demo. You'll see that anonymous access level has been restricted here. It's only private access. You have to have some security credentials, whether it be through a thing called a SAS token or an RBAC permission to be able to get in and work with this. Now, this was changed a little while ago from earlier versions, and this follows Microsoft's Secure by Default feature. I'm going to accept this at this time, but I'm going to show you where you can go in and change that if you need to make this accessible. So I've now got a storage account that has a container in it. Now let's go down and take a look at some of these other features. Under the security blade, I'm going to take a look at the access keys, and the encryption keys. So those encryption keys are the ones that I mentioned earlier when we created the storage account. I could change this after the fact. And so I can take a look at switching from managed Microsoft managed keys to your customer managed keys. I also have access keys that I could then use to access the storage account. Now you'll see that there are two keys here that provides the capability for what's called key rotation. I'm not going to get into this. This is covered in other courses, and it's usually beyond the scope of a developer. You don't have to worry about key rotation. These keys are often stored in an area called Key Vault, which we'll cover in another recording, that you as a developer would usually go to claim those keys from the storage account and then use them to access the storage account and the resources in it. And that's all you're going to need from an application developer. But it'd be up to the key management group that would then publish those keys into the storage account for you to work with. I'm going to talk about a thing called a SAS token, or shared access signature, which is a way for you to now discreetly give certain control to certain areas of the storage account at the storage account level. I'm going to stress that because I'm going to show you a SAS token at the individual blob levels that exist within a container. So it says what kind of access are you giving access to. In this case, it's blob only. That's the only type of objects I have in here. If I had files, shares, or tables and queues, they would be listed here. Do I want access to the service, the containers? And then what kind of permission? Read, write, modify, delete, create. Where do I want it to come from? So I can specify specific IP addresses. When do I want it to start and when do I want it to end from a time perspective? So all sorts of ways to manage that through a SAS token. Okay. Now getting into the configuration, this is where I wanted to get to. You'll see that allow blob anonymous access has been disabled by default now. This was not the case earlier on in Azure, but that now is the case. I'm going to switch this to now allow for blob access so I can do the demonstration I want to show you for accessing control to the actual blobs themselves. So I'm going to save this. I'm now going to switch back to the containers. And you can see that it's still marked as private. I'm now going to come in and change the container properties and change the access level from private to container, anonymous read access for the containers and the blobs inside of it. So what I've got now is my AZ-204 demo container that has been changed from private to container access. Let's go in and copy some objects into here. So I'm going to upload files into this location. So I've uploaded an object to this container. If I take a look at the properties of the object, I'm going to generate a thing called a SAS token for it in a minute, but you'll see that it has a URL to access this object. I'm going to copy that. I'm going to open up a private in-browsing window, and you'll notice that the storage location is the storage account name .blob.core.windows.net. I'm going to point this back out when I get into the PowerPoint slide. Then it's the container name and then the name of the object. I'm going to access this file, and you can see that it's my badge for being a Microsoft certified trainer. So that is anonymous access. I didn't have to provide anything for that. So I'm now going to switch this. I'm going to go back into the storage account, and I'm going to switch it from anonymous access. I'm going to switch it back to private. Okay. So all I've done is I've made the container private. I'm going to refresh this screen. And you'll now see it says the specified resource doesn't exist. I really like this message as well because it's not says I don't have access to it, because that would be a case of what's called footprinting. If a person said, hey, you just don't have access to the file, I know that the file now exists, and I would use maybe some brute force attempt to try and compromise that image. But I don't know if it's not there because it's not there, or I just don't have access to it. So by simply changing the permissions to the container, I'm still using the URL to the object, and now it's restricting that access. So now what I'm going to do is I'm going to come back into the container, and I want to now generate a SAS token. Now these are going to be talked about in the recordings. So I'm going to create a SAS token that, very similar to what I talked about when creating the storage account and creating a SAS token for the storage account, this is now going to create a SAS token for this object. I can talk about what kind of storage policy do I want it to have. If this is assigned at the container level, I can show you how to create that. And then I can select the kind of permissions that I want to be able to allocate for this SAS token. When does it start? When does it end? Do I want to restrict it to a known set of IP addresses? And what protocols do I want to use? So I'm now going to take this connection string for the blob. I'm going to change this. And you'll notice that it's much longer now. I'm going to go back in and we'll show you some of this. The first part is exactly the same. It's the storage account name .blob.core.windows.net, the name of the container, the name of the object, and then there's a whole bunch of information here that talks about the type of permission, what times it start, what times it end, what IP addresses does it have, what is the permissions that you have, is it read, modify, and then what's called the token, which is the secure information accessing this object. I'm just going to hit now. And so now again, I have access to the object. So showing you that you can now secure these objects, but they're still publicly available. It's not part of this class, but I do want to talk about that there are better ways to secure this, especially from an internal perspective. This is not your job as a developer. This will typically be picked up by the administrators that build these environments for you. But at the storage account level, if I get into the networking features, security networking, I can do certain things. Do I want to have public access? Yes or no? Do I want to make it available from specific networks? So I can manage the networks that I want to have access to this and restrict it to only internal networks. I can create a thing called a private endpoint. And what this is going to do then is actually give an IP address to your solution. And it's going to create an IP address in your network solution. So if you had, say, a front-end website that was on a 10 dot network, you could put a private endpoint on that network that would then be used to access that local IP address in the network to then gain access to the storage account. So lots of great ways to secure this information without making it publicly accessible. Okay? One more thing I do want to show you is at the storage account level, within the configuration, you can change the default behaviors from hot to cool to cold. Now, this is just setting up what the default value is. So I'm going to go back into the container and show you the object that I created in there. And you'll see that it is hot inferred. So it inferred or inherited that from the storage account. Now, I can change that level, and I can change it from hot inferred. I can actually get it into changing the tier. I'm going to switch it from hot to cold. Now, in the next recording, we're going to talk about the difference between hot, cold, and cool and archive, but this is now set to cold. Now, I'm going to go back into that access, and I still have access to it, but for all intents and purposes, at the human eye level, that object looked like it was accessed at exactly the same speed as it was when it was hot. So these demonstrations don't really do it justice, the difference between hot and cool and cold. The performance level, and we're going to show you in another recording, the benefits of hot, cool, and cold. I'll get more into it in there. But this is not meant for accessing a file at a human level, accessing a file as I just did. This is meant for your applications that might be populating a website that has thousands or tens of thousands of images and videos of your products that it's going to need to access. And so hot tiers can have a significant difference in performance with an application level to large volumes of files, as opposed to what I'm doing here, just accessing an individual file. So please don't think that hot, cool, and cold is going to be just, difference in cost. It's a big difference about performance, and that's we'll cover again in a recording section that we talk specifically about lifecycle management for your storage. Now I'm going to copy another file up in here and just show you some of the things that happen. Again, I'm going to add up another file. And this time put in some images of some desktop images I have. And you can see it's got hot inferred by the default. Now I'm going to go back into the storage account and change the default value from hot to cool. I'm going to save that. And what you'll see is by doing that change, going back into the storage account and then into the container for that storage account, and you'll now see that that file that was hot inferred now indicates cool inferred. Now the file that was explicitly defined as cool, hot, or cold will keep that definition. And you'll see that in another recording about storage, you can actually write, modify, and work with all these attributes at the code level. So whether you're writing files or reading files from in there, you can modify some of these, but you're just seeing the default attributes and what happens to defaults if they get changed, or if you define and change from an inferred value to something specifically, it retains that value. Okay? So let's go back to the slides. So you've just seen a big tour of the portal creating and using a variety of the services available through an Azure Storage account. Now, we showed you all these features that are showing this screen. We're seeing that you have the different types of accounts, whether it be standard or premium. We saw the restrictions that went through. We saw that the different types of replication that we had of LRS, ZRS, GRS, RAGRS, GZRS. We also showed you that there's the different tiers that you have of hot, cool, cold, and archive. That's an important one, especially from a developer perspective. And a lot of people will talk about, oh, well, hot's more expensive than cool or cold. Well, the answer is it depends. Hot to store something is, yes, more expensive than cool or cold, but it costs more to actually access it. So if you're going to use these services on a regular basis, it could actually be more expensive to access something over the cold tier than the hot tier, because the per data transaction is higher than it is at the hot tier. So price isn't the only just raw cost. You want to take a look at the volume of data as well as the type of access to make that choice of hot, cool, cold, or archive. And remember that archive storage is truly archive, and its access tier is potentially the SLA is 15 hours to rehydrate that information back into either a hot, cool, or cold tier, which is nearly instantaneously accessed. We showed you that in that hierarchical structure of blob storage, a blob exists in what's called container storage. Containers are hierarchical. You see that in the storage account. You then get containers. Those containers have different access levels that you're working with, and then the actual blobs exist within those containers. And you can either use SAS tokens or RBAC permissions to then control granularly access to the objects within inside of the container, inside of the storage account itself. So generally, by default, SAS tokens are what you use to access the storage account. And you might want to consider moving that to RBAC, or the role-based access control, to have granular access to the individual objects, and would probably be the more secure method to be able to get and work with this. We saw that by default, all data is encrypted at rest. We've got 3 copies, as well as data is going to be encrypted at transit. Now, data is going to be secure in transit. It's not encrypted. That's a difference. So while you're on the same wire as maybe other customers inside of Azure, it is using secure networking that keeps your data secure in transit. It's not encrypted. If you need encrypted traffic, it has to go through a VPN. And if you take any of our Azure networking courses, you can take a look at how you can use encryption to be able to provide for the encryption in transit. There's also some features of SQL covered in the SQL courses that we'll talk about, being able to have that end-to-end encryption capabilities for encryption. But by default, in a storage account, the transmission of that data is secure but not encrypted. We saw that you can access it, also the last one there, using the SAS tokens to be able to come through to control the kind of access, where it's coming from, as well as being able to put a time limit on it. When you take a look at the storage encryption, we saw that you had the capability to encrypt all data at rest, and that encrypted is going to be kept at an encryption of a storage account that you could either have that key be managed by Microsoft or by you as the customer. And you saw some of the features that if you were going to get into that, you might want to have your keys stored also in something like Key Vault. So that brings us to the end of this module that talks about the general purposes of a storage account, focusing mostly on the unstructured features of blob storage. We didn't get too deep into file shares, tables, or queues, but blob storage from a modern application perspective is where you're going to want that durable storage. So in any of the other recordings where we've talked about whether it be in app services, container apps, Azure Functions, if you needed to make the data available in a durable manner, you're either going to an Azure file share or into some other form of blob storage, file shares, table storage, to be able to keep that information more durably. So let's go into the review questions. The first one is, what type of blobs are used to store virtual hard disks or VHDs for your VMs? You want to go ahead and pause the recording? It wasn't talked too much about in the books, but in my demonstration, I showed you that you could store either block blobs, page blobs, or append blobs. And the general block blobs is how you're going to store that unstructured data, the XLSs, the MP3s, that kind of unstructured data. And we saw that page blobs was specifically used for things like hard drives or the VHDs. Question number 2, what type of storage account is recommended for most scenarios using Azure Storage? Go ahead and pause the recording. Now, that's a pretty broad question, that what kind of storage account. We saw that a storage account is regionally based, so that's not going to fit into it. We saw that you could have either a standard V2 or a premium storage account, which is then going to be restricting the type of replications that you're working with. And so in there, I would say what they're looking for as an answer is the standard V2, which is going to be used for most scenarios for Azure Storage. It gives you the most possibilities for the type of data that you can store, as well as the type of replication that you're working with. So that brings us to the end of module number 1, where we've taken a look at what an Azure Storage account is as a regionally based unit of storage that has a type of replication that's associated with it. If you need to have different types of replications, you're going to need a different type of storage account. And if you want it stored in a different geographic location, you're going to need a storage account for that. So the key here is storage accounts are a type of replication that is unique to a specific region. All the data stored in that storage account is going to share those attributes that you're dealing with. We then saw different ways how you could securely store that information using encryption and using ways to access that information either through RBAC or through SAS tokens. So thank you for joining me on this storage journey, and we'll see you in another module.